Good evening, my dear class 11th standard students and even the class 12 standard students who want to clear the basics of integration and areas, which is a must for your physics and of course for mathematics. But we are going to deal from the physics point of view, whatever we require, the understanding of the concept of this calculus part of integration and areas. All of this in today's session with your captain navigating this ship in this rough sea. And the sea is rough because we are talking about the JEE entrance examination. So we need to be sure that everything is absolutely clear. And you don't have to worry. The ship is in the right hands of your captain who has been navigating these rough seas for more than 13 years. All right. So let's begin the class with full Josh, full energy. Quickly smash that like button down there and also subscribe to the Vedantu J English channel, which is your number one J English channel, right? Hi, Abhijit Vignesh, welcome. Taruna, Marut, Ram, welcome. Hema, good evening. Dhoriman, Ramesh, Cupcake, who is this? Welcome, 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 everyone. So, in the previous lecture, we have already seen slopes and derivatives. Quickly smash the like button if you have not yet done that for the previous one. Every session, 6 o'clock for 11th standard, 8 o'clock for 12th standard. And after every session, we give a homework. And some of you solved it, some of you did not. I was not very happy because not many people solved the homework question. You thought, oh, somebody has answered it. Why should I answer it? No, don't do that. See, that will bring in that consistency in you. You will feel guilty when you don't do it, and that will bring in that behavioral change of being consistent. And once you follow a routine, automatically many things start falling in place. All right. So even if you're watching it recorded, that's perfectly fine. Yeah, very good. Many of you answered it correctly. The question for the derivative, amazing, amazing. Vignesh, Darshan, Chandru, Atul, Kiran, Sulochana, welcome. Very good. To God, to to go Doberman. Wow, what a name. Arul, very good, very good, very good. Amazing, amazing. So let's begin. Yes, the mass is here and the Thalaiva also of physics is here. Okay, so let's begin, guys. And I really want that in 2027, you all should be here. Okay, all the names that I'm seeing in the chat box or in the homework comment section, your name should be here very soon. I mean, all India rank 15. Imagine how proud you will be feeling. 92, 273, 390. These are all the Vedantu students cracking JEE Advanced this year, guys. That is insane, right? So let's begin, guys. Okay. Now, when we talk about areas, for normal geometries, we know how to calculate the areas. For example, say the diagram is a triangle. Okay, 1 second. The diagram is a triangle. Okay, then the area of a triangle, area of a triangle we know is half base multiplied by the height. We know this standard form. If it is a simple rectangle, then we know that the area of a rectangle is nothing but length multiplied by the breadth. Length multiplied by its breadth. These are all simple things. Similarly, we can find area of a trapezium and God knows what and all things. Like for example, if it is a trapezium like this is a trapezium with two parallel sides, then the area of a trapezium is nothing but your half multiplied by the height multiplied by the sum of the parallel sides. Parallel sides are this one and this one. You add them and multiply it with the height of the trapezium. That will give you the area of the trapezium. So these are some standard things which everybody is accustomed to. Other things are also there. Area of a sphere and God knows so many things. Area of a circle, everything we know, right? Area of a circle also we know. So area of circle is pi into r square. Now we need these areas for solving many questions of graphs. Many questions of graphs need the calculation of areas. Like you will see in thermodynamics of physics, to calculate the work done by a gas, you need the area under a pressure volume graph. You will see in the chapter of collisions, the area under force and time gives you the concept of impulse. The area under current with time gives you the charge which flows. So many places the concept of area will come. As long as the areas are standard, one of these, it becomes very easy. So coming to the point, the concept of the concept of the concept of areas is widely used in graphs, basically in physics. For example sake, the area under the velocity versus the time graph gives you the displacement, gives you displacement. Another example, the area under current versus time graph gives you the charge which flows. Another example, the area under pressure versus volume graph gives you the work done by that particular gas. Like that, so many examples are there, my dear students. Okay, so many examples there where you need to calculate the areas under the graphs to find out a particular physical quantity. Like the derivatives deals with slopes. Today we are dealing with finding the area under these graphs. Okay, mindset. I will answer your question after some time, but I don't want to break the flow. Okay, so hold on. Okay, let me not break the flow. Now let's take an example. For example, say this is our y-axis, this is our x-axis. Remember, x-axis is always your input axis and the y-axis is your outcome. You tell me x, I'll tell you what is y. You tell me x, I'll tell you what is y. So say for example, in this scenario, if I have a graph which goes like this, then maybe like this, oops, like this, like this, like this, and then maybe like this, and then maybe like this. Chumma, I have made some random graph. If I ask you that, hey, listen, this is a graph of some function y is equal to f of x. Okay, some function is there. Y is f of x. For every x, there is a value of y, unique value of y. Then the area under the graph, of y versus x can be easily found because I can now break this down. Now I can break this down into maybe something like this, like this, like this. Even if you want, you can break it down like this, like this, like this. So you can see a lot of triangles and rectangles are formed. Can you see that? So many triangles and rectangles are formed. Like for example, I can shade the triangles maybe in pink color over here. This is your triangle over here. Another triangle over here. You can see that, right? Another triangle over here. And so many rectangles are also there. So many rectangles are also there. Like this one over here, this one over here, right? And even this one over here. So very easy to calculate the area under the graph. So it is nothing but the sum of the areas of basically the triangles and the rectangles. Triangles and basically the rectangles. Very easy to calculate it. So if I know the heights, base, everything, the values, I can easily calculate it. Everybody agrees with this concept? Give me a thumbs up quickly. Yeah. Abhijit, the first lesson of 11th standard will start the following week. I mean, next week in fact. Okay. So we are clearing the basics before you begin so that there are no doubts. Or else what happens? We start with chapter 1, immediately you are like blank. Okay. Fair enough. Now, iota is also involved in some physics graphs, like you can involve complex numbers, like in AC and so many other places, alternating current. So yes, you can. There are a lot of things which can be dealt with complex numbers. Okay. The problem happens. The problem happens when our y function. What is this? The problem happens when my God, when our function y is equal to f of x. My goodness, why is this like this? Happens to be some curve like this. Some curve like this. That's where the problem happens. Because now, one option with us is using our old school method where I make small blocks over here like this, maybe. I make small blocks over here like this by drawing many lines like this, like this, like this. Okay, I'll have to make small blocks like this. And then here also I will start drawing the horizontal lines. Okay, and you might have studied this in school level. You count the number of full squares, half squares, etc. All these things. And then you try to figure out how much is the area under that graph. Okay, you count how many squares are being complete. If you plot this on a chart paper or a graph paper, you can measure it. But using the method to find the area under the y versus x graph, I can use the areas of the squares, okay, by counting, but this will not be exact. Rather, I should definitely be careful. It will be an approximate value. This is because it is not so accurate. Not so accurate. You might miss out a square, and plus, some half squares will be there. Whether it will be exactly half, 1/4 square, 3/4, so many problems will happen. So this method is okay if the size of the squares is small. So very important. If the size of our squares is small, is basically small, then it is better, but it will always have some inaccuracy, but it will always be approximate. It will always be approximate. It will never be accurate. Okay, I hope this you understand. Yeah. So now, do we have some way to measure this area exactly without having any kind of approximation? Yes, very close to the answer. Can we get to the exact answer somehow? The answer to that is yes. But how do we do that? So the idea comes like this. Say, for example, here is what I do. I will draw vertical lines like this. I will draw vertical lines like this. Okay. And let's say I want to measure the areas of all of them. Let's say I want to measure the areas of all of them like this. And maybe I want to measure it from a point to another point. Let's say this point over here, this point over here represents x1 coordinate. This point over here represents x2 coordinate. I essentially, what do I want to measure? is this entire area. I want to measure this entire area somehow or the other. How do I measure it? So I have drawn some vertical lines. And what I do is, I will say each vertical line is separated by a small distance of delta x. Each vertical line is separated by a small distance of delta x like this. Small distance of delta x like this. Each of this rectangle, I can say maybe this is the height, 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 like this. Their heights will be the values of y at x1, x1 plus delta x, x2 plus delta x, like that. So at x is equal to x1, this is the height of that rectangle that you can see. So at any given place, this is basically the height. So this is, let's say, y1. Then you will have maybe some other y. And finally, you will have y2 over here. But in general, if you notice, in general, I'm talking, at any given x, which has a width of the rectangle as delta x, the height of that rectangle will be basically y. The height of the rectangle will be basically y. Are you able to sense that? Are you able to see that? So if I vaguely, approximately try to find the area under it, the area under y versus x from, this is very important, from x1 to x2, this will be nothing but the sum of the areas of these rectangular strips of height and width. What is the height and what is the width? The height is basically y in general, and the width is basically delta x. But there is a catch over here. This is not exact. This will be approximate. This will be approximate. Why? Because I am missing out on some areas. Like for example, this one I'm not counting. This one is missed. This one is missed. This one is missed. This one is missed. This one is missed, and so on and so forth. Everybody is able to see it? Guys, am I audible and visible? Let me know quickly, because I think there was some internet problem. Just check it out. If am I audible? Yeah. Okay. So sorry for that interruption. I don't know, some problem happened, so I had to restart my system. Anyways, so coming back to the concept. Yeah. So we were talking about the area under the y versus x graph from here to here, from x1 to x2, and we had broken it down into small strips, and we calculate the areas of these rectangles from here to here. And when you calculate the areas of these rectangles of each of width y and delta x, the problem was it was not so accurate. This was not so accurate because I'm leaving out some gaps over there. So how do I make this approximate into exact? How can I make this exact? The only possible way to make this exactly equal to, the only possible way to make this area under y versus x from x1 to x2, exactly equal to is, if at all, let's say this is x1, let's say this is x2, the only possible way is you make these rectangular strips so small, so small and tiny that there is no red part which I was showing over here. The red part is coming because these strips are wide. The delta x is a big value. maybe 0.1, 0.7 to 3.5, whatever. But if you make it very, very small, then these two lines will come very, very close to each other. It will be like for every point, it will be like for every point over here on this curve, for every point on this curve, you are taking two parallel lines of height some y and width which is very, very small. So you break it down into very, very small lines. Break it down into very, very small strips basically. Okay, like this. And then you will get a fairly accurate answer. What is it called when you make the width or basically make the thickness or make the change very, 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 very small? What is it called? Yes, my dear students, you have learned that in the class of derivatives. When you have anything whose width is very, 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 very small, whose width is very, 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 very small, delta x tends to 0, that is, you call it as dx. The height of this is still going to be y only. The height of this is still going to be y. So the area of this particular strip over here, the area of this particular strip will over here will be the area of those very small strips of width dx and height basically y, and you have to add them all. So the sum of the areas of those small strips whose width is a dx and height is basically y. Yeah, then it will be accurate. But remember, these lines which I have shown is for representation purposes, but technically I will never be able to draw two lines so close using this pen because the pen has a thickness, the board has a limitation of pixels, your camera, your screen, everything has a limitation of pixels. Imagine we are not limited by pixels or the thickness of the pen, then those lines can come very close, approaching zero, but not exactly zero. There is a small width over there, and that is dx. This particular sum of such rectangular strips, how many are there? Think about it. Can you count them like 10, 20, 100, 2000, 5000? Can we count them? No, right? There will be infinitely many such strips. So sum of infinitely many such areas of small strips of width dx and height y, when you want to represent it mathematically, this is how we represent it. The sum of such many strips is represented by a symbol called as the integration symbol. This is the symbol of integration. This is the symbol. This is the symbol of integration. That symbol represents the sum, integration, sum of many, many small numbers, but infinitely many numbers. And the area of any such strip will be height multiplied by the width, which is dx. Height is y, width is dx. So y dx, y dx, y dx, y dx, y into dx, y into dx, y into dx, y into dx. You add them up, that is integration. But I need to specify from where to where, or else I can't just keep on taking many strips till infinity. I want area only between these 2 points. So that is why I put the first point below over here, below the symbol of integration, and the last point till which I want to measure it on the top. This is usually called as the upper limit of the integration. This is called as the upper limit of the integration, and this is basically called the lower limit, the lower limit of the integration. This is called as the lower limit of the integration. So this is how you represent it. How is the formula, etc.? We'll come to it. For now, just understand the meaning of this symbol, why you need to write it like this, and what is this upper limit and this lower limit. Is this absolutely clear? What does this symbol limits? Why is it written as something into dx? So let me give you another example over here. Say we have written it down like this. Say we have written it down like this. Integration of, say for example, x square dx, and here we put 1 to 4. What does this mean? What does this mean? Okay, think about it purely in the graphical way. Think about it purely in the graphical way. Okay, so this is your x-axis, this is your y-axis. Okay, always whatever multiplies by dx, that is exactly our function. So this x square which you are seeing is basically your y. So y as a function of x, that y as a function of x is only x square. It is a quadratic equation. It is going to be a curve. So that curve will probably look something like this. That is your y is equal to x square. Integration means I am finding the area from where to where, 1 to 4. Point 1 might be here, 2, 3 and 4 might be somewhere over here. So if I show a vertical line here and here, what I am trying to find is basically the area under the curve between these 2 points. That is what I am trying to find. Is this absolutely clear, my dear students? Is this absolutely clear what we are trying to find over here if this was given to you? Okay, you have to think like this. Whenever integration comes, means you are trying to find the area of this with respect to x, from x going 1 to 4, 1 to 10, 2 to 100, whatever, lower limit to upper limit. That is the meaning of it. Perfecto. All right, we'll figure out the area later on. For now, I'll just keep it like this only. We are not going to find the area because we have not yet seen the formulas for integration. For now, we just know what does integration exactly mean. So basically what integration means is the area under the curve with these symbols and all of that. So I'll block this particular result. Okay, this is the formula till now, the main sense of integration. Sir, but how do I solve this, sir? How do I solve this, sir? What is the formula for this, sir? Well, let me tell you, there are definitely formulas for it. But before that, let us see how do we use these formulas. Okay, how do we use these formulas and what are those formulas? For example, if you remember in derivatives, if derivative of e raised to x comes, derivative is e raised to x. Derivative of x raised to n comes, it is nx raised to n minus 1. Derivative of sin x comes, it is basically cos x, right? Let me tell you, in integration, it is exactly opposite. In integration, everything is exactly opposite. In fact, if for example, if I have a function, if I have, let's say, if I have, let's say, a function and I call it some g of x, some g is a function, and I take the derivative of it, I get f of x. So I take the derivative, I take the derivative, derivative of that function, I get f of x. If I take the reverse exactly, that means if I try to find whose derivative is f of x, I get g of x. That antiderivative is also called as integration. Antiderivative is also called as integration. But there is one problem when I find the antiderivative, and let me show it to you with a live example. Say I give you some function like this. Say sine of x. Sine of x is g of x. What will be the derivative of this? What will be the derivative of it? We all know sine of x derivative will be nothing but cos of x. But let's say my function is sine of x and plus 4. Sine of x plus 4. We all know sin x's derivative will be cos of x. 4 is a constant. Constant's derivative is 0. So it will still be cos of x. What if I had the derivative to be found for sine of x minus, let's say, 7. Well, sine x's derivative is still cos of x, but derivative of 7 being a constant is 0, it will still be cos of x. That means when I try to go reverse and somebody just tells me that, hey, the derivative of a function is cos of x, and can you figure out what that original function was? Then I am in a dilemma. I have an issue where I do not know what constant might come. I have to give that benefit of the doubt that maybe there might be a constant. It could be 4, 7, root, whatever, whose derivative will become 0, which we cannot get that information. We cannot find out what that constant was unless we are specifically told. So we need to give that benefit of doubt, and that's why we put a constant of integration. That's why we put a constant when you go the reverse, which is called as the integration, antiderivative or integration. Is this absolutely clear with this example? Let me know. Yeah, everyone with me? We'll talk about definite and indefinite in a bit. Hold on, black hole. Hold on. But for now, did you understand why, while finding derivative, we miss an information when we go reverse? Because when you take the derivative, what happens is the constant's derivative becomes 0. So when we go reverse, we miss that information. So we need to put in that benefit of doubt. So that's why we should usually put g of x plus c. G of x plus c. So here is how I put it. If f of x is the derivative, f of x is the derivative of g of x plus c, then this is very important, then it implies that g of x plus c is the integration, is the integration is the integration of f of x, is the integration of f of x. So g of x plus c is the integration of f of x. Is this absolutely clear? G of x plus c is the integration or the antiderivative of f of x. But do I know the symbol of integration? Of course I know it. So integration symbol is basically this one. We have just seen it. This is the symbol of integration. Integration of f of x. That means like this. But always you have to integrate it with respect to something. So the answer to this. Will be what? This g of x plus c. The answer to this will be nothing but g of x plus c. This is the answer to this. Is this clear? Is this clear, my dear students? So g of x derivative is f of x. So integration of f of x will be g of x plus c. C is called as the constant of integration. So this c is called as the constant of integration. Constant of integration. We do not know the value of the constant. It is a benefit of the doubt because we do not know the value. We are not sure what is it exactly. So we call this process as indefinite integration. What do we call this? We call this as indefinite integration. Indefinite, not defined. C is not known. So indefinite, I'm not sure. Indefinite integration. Indefinite integration. Let me give you a simple example of this. Let me give you a simple example of this, guys. Say, for example, I ask you, what is the integration of cos of x dx? Immediately you should think, this guy whose derivative is cos of x. Immediately think, whose derivative is cos of x? Come on, my dear students. Whose derivative is cos of x? Abhijit, you are in 9th. Are you able to understand it? If you are in 9th standard and you are able to understand this, no, I will feel very, very happy. At least 50% if you are able to understand. Sin x's derivative is cos of x. Oh, so the answer to this will be sin of x. But I have to Oh, this, why dx? I'll come to it. Hold on. I have to keep the benefit of the doubt because any constant, if it is present, the derivative of the constant will become 0. So sin x plus 3 derivative will be cos x. Sin x minus 100 derivative is cos x. So what that constant is, I do not know. So I need to put that benefit of the doubt. Okay. Why that dx? Remember when we found out the areas, we'll be coming to that area part, right? Or we did it just some time back. When we find the area, what do we do? Height into base. Height into base. What is the height? Y. What is the base? It is basically dx. So that is the reason why you need to multiply with dx. Okay, you cannot just write down integration of y. No, it has no meaning. Or integration of x cube. No, it has no meaning. If it is something, it has to be with dx. Just like there is no meaning of dy by nothing. Always it is dy by dx or derivative of sine of x with respect to x. So you differentiate with respect to something. You also need to integrate it with respect to something. So that dx is always the thing with which respect to you integrate. So y happens to be that function. It is basically that function, and this is integrated with respect to dx. Okay, so always that dx will come. Do not ever miss that dx symbol. Is that clear? So let's see if you guys can figure this question out. What is integration of just dx? Okay, integration of just dx, sir. I can write it as 1 multiplied by dx. I think now it will be clear. Whose derivative is 1? Just think whose derivative is 1. I know dx by dx is 1. In fact, derivative of x plus any constant with respect to x, which will be also 1, because constant's derivative is 0. Constant's derivative is 0. Oh, sir. So that means the answer to this is x plus c. Derivative of x is 1, or any x plus c is also 1 only. Answer is x plus c. Guys, got it? So now it will be easier for me to explain you the formulas of integration. Observe. If I ask you what is the integration of cos x dx, immediately you will jump and tell me, sir, the answer is sine of x plus c. If I ask you what is the integration of sine x dx, let's see how many of you are able to jump and answer the question. Whose derivative is sine? Cos derivative is negative sine. So if I have negative cos derivative, it will be negative of a negative, which will become positive. So shouldn't it be negative cos x plus the benefit of the doubt? Because cos x's derivative is negative sine. So this negative with that negative will make it positive sine. Is that right? Everyone with me? Similarly, if I tell you what is the integration of e raised to x dx, immediately you will think, whose derivative is e raised to x? Oh, wait a minute, it was a very special function whose derivative was the same thing. So the integration will just be e raised to x plus that benefit of the doubt, constant of integration. Excellent. Then, if I tell you what is integration of 1 by x dx, or just let's say first let's start with just dx for now. I gave you the answer right over here. Just integration of dx is simply put x plus c. X plus c. Sir, what is the integration of 1 by x dx? Oh, let me think, guys. 1 by x, 1 by x. It was the derivative of somebody. Whose derivative was 1 by x? Come on, think about it. 1 by x was the derivative of logarithmic, yes, function of x. So it is nothing but log of x to the base e plus the constant of integration. Log x's derivative was 1 by x. Oh, yes, sir, I remember. But then comes the final question. Okay, so these are the basic functions. There are many functions that you will learn, many methods of integration. You learn calculus for 2-3 months. Yeah, if you are in a normal batch, you will see, you will learn it for 2-3 months, meaning it includes derivatives, application of derivatives, limits, functions, integration, applications of integration, areas, everything. So that takes a good amount of time. So here we are just understanding the concept of integration for now today. X raised to n dx. Try to think whose derivative is this. Obviously, some benefit of doubt will be there, which is plus c. But x raised to n, sir. See, if I take the derivative of x raised to n with respect to x, then the answer will be n x raised to n minus 1. No, sir, I want only x raised to n, sir. If I want x raised to n over here, then maybe I will, if I want the answer over here to be x raised to n, then this should be probably n plus 1. So derivative of n plus 1, derivative of x raised to n plus 1 will be n plus 1 will come outside and reduce the power by 1. So it will be n. But sir, n plus 1 was not there, no sir, over here. So why have you put over here? So I have got an idea. How about this? 1 by n plus 1. If I put, then this will also be n plus 1. So this n plus 1 and n plus 1 will cancel. Oh, so you mean the answer to this will be x raised to n plus 1 by n plus 1. This guy's derivative will be x raised to n. Getting it? So derivative of x raised to n plus 1 by n plus 1. What will happen? N plus 1 will come outside. Power of x will reduce by 1. So that is there. And n plus 1 from here is as it is over here, which will cancel out. So I am left with x raised to n. So yes, this is the answer to this. Is this absolutely clear, my dear students? Everyone? So these are the formulas which you must 100% remember. This entire thing, I'm blocking it, guys. All these formulas you should know. Okay. Abhijit, derivative, right? I have explained it in this class. Did you attend this class, my dear? I've explained what is the concept of derivative and slope, and we did a beautiful lecture on finding derivatives by geometrical and analytical method. It's a beautiful session. Please check it out. Okay, we have done derivatives in, in a proper class. Okay, so please watch it, Abhijit, Bhuvan, in case you have not watched it. Yes, Abhijit, only log to the base e. Yeah. If it is some other base, then you have to convert the base using logarithmic formulas. You will learn that in log. We'll not get there because then we'll go too deep into mathematics. Let's just understand, the concept of integration and all of that. Yeah, there are many rules: integration by substitution, integration by parts, derivatives of multiplication, UV, everything is there. We'll do it step by step. For now, I just want you to get the hang of it. When time comes, I will explain all those things. Okay, don't worry. Okay, so over here, my explanation to this was, see, if it was just derivative of x raised to n with respect to x, it was nx raised to n minus 1, which is not what I want. But if I have derivative of x raised to n plus 1 by n plus 1, that n plus 1 will come outside, and I'm just left with the derivative of x raised to n plus 1. So n plus 1 comes outside, and that n plus 1 minus 1 should come, and this whole thing by n plus 1. N plus 1, n plus 1 cancels. What is remaining is x raised to n. So this guy's derivative is x raised to n. So this guy's integration is this. That's what my point was. That is how I wrote this formula. Is that now clear? Yeah. No, chain rule is not there in integration. Chain rule and all that is not there in integration. Okay. We will have a separate class on those advanced topics of derivatives and integration separately. For now, let's do this much. Okay. We'll do UV rule, integration, substitution, some basic things, maxima, minima in a separate class. For now, this much is enough. Okay. Sir, now I understood the formula, sir. So can you tell me any more rules that I need to remember? Yes. Few more rules. See, if it is integration of some u plus v or minus v dx, then you can integrate u with respect to dx separately and that another function with respect to x separately. If it is minus, minus, if it is plus, plus. So you can separate out the things. Another important thing, if there is a constant and you have u dx, that constant can be brought outside and you just integrate it as it is. This is another important rule which you can use. So basically in this case, we have brought out that constant, and here if it was plus or minus, the same things will be coming over here with separate integrations. So these are the two important things which you might need in some question solving. Okay, sir. I understood it till here. Sir, can we do some questions? Why not? Let's do some questions so that you guys get a hang of it. Okay, here comes the first question, guys, on your screen. Integration of x square dx. Integration of x square dx. Integration of x dx. Integration of x raised to minus 1 dx. Integration of root of x dx. How much are these things? Okay, let's do these 4 examples for now, then slowly we'll progress. Starting off with the first one, x raised to 2 dx. This is x raised to n formula. Yeah, x raised to n formula. So what was the formula, guys? The formula was n plus 1 power of x and divide by n plus 1. So the power over here is 2. So it will be x raised to 2 plus 1 by 2 plus 1. Do not forget that c. So it will be x raised to 3 by 3 plus c. Perfect. Done and dusted. How about this? This is as good as saying this is x raised to 1 dx. So basically x raised to n formula. That means this will be nothing but x raised to 1 plus 1 by 1 plus 1 plus c. So this will be x raised to 2 divided by 2 plus c. That's it. That is the answer to this question. Is that right? Let's do this question. Okay. So what is this? This is nothing but x raised to half, root is half, into dx. Okay. So x raised to n formula. So x raised to half plus 1 by half plus 1 plus c, the benefit of the doubt. Half plus 1 is 3 by 2. So x raised to 3 by 2 by 3 by 2 plus c. So you can bring that 2 on the top, 3 below. So x raised to 3 by 2 and plus c over here. That is the answer for this integration. But sir, what about this? For what about this? Lot of you might be facing an issue if you use x raised to n formula. Minus 1 plus 1 by minus 1 plus 1 plus c. This is 0. So there is a problem. The moment I do this minus 1 plus 1 and here also minus 1 plus 1 and this is plus c, what will this be? This will be x raised to 0 by 0 plus c. X raised to 0 is 1. So 1 by 0 plus c. What is this? This is not defined. So is the answer not defined? Wrong. Actually speaking, think of this as the correct way to solve this is x raised to minus 1 is 1 by x dx. Oh, 1 by x, sir, I know it. It is nothing but log of x. So log of x to the base c plus c. Then you'll be like, sir, wait a minute. How did you know for this power only I have to go to log of x? Why I did not do that log here, there? And how do I know this formula will not work? Is there any condition? Yes. When I gave you the formulas deliberately, I missed out on an information because I wanted you to see it in a live example. So this formula when you use, remember this value of n can, in this, the value of n can never be minus 1. If at all it is minus 1, then basically you use this formula. Only then you use this formula. That is the only exception. Like in inorganic chemistry or in chemistry, you have exceptions. So this is that, I won't say exception, but it is very natural that this guy's derivative you can get here, this guy's derivative is here. So naturally the integration should be log of x. So it cannot be used with this formula. Okay? Is that clear, everyone? Black hole, everyone? Understood? So only for negative 1, do not use. When negative 1, use 1 by x. So this, whatever I have done over here, is not correct. So never ever do it. This is deliberately I did it so that you see your mistake. Let's go to the next example coming up on your screen, and here it comes. What is integration of sine x minus 5 cos x dx? Sine x minus 5 cos x dx. What is the integration of e raised to x minus x plus 1 by x, the whole thing dx? Okay, come on. These are the next examples. Let's see how many of you are able to solve this. Okay, When I see minus or plus, I know I need to separate out those integrals. So this will be integral of sine of x dx separate, negative sign is there. Integral of 5 times of cos of x is also there. I gave you one more rule though, if you remember. And what was that rule? That if you have a constant multiplied by the function, the constant comes outside. So it will become like this, 5 times cos of x dx. No need to put that 5 inside, that 5 comes outside. That's it. I gave you that rule right over here. Right over here. If there is a constant, that constant comes outside. And whenever it is plus minus, you can separate out those integrals. So let's separate out already, and the constant is also out. What is integration of sine of x? It is negative cos of x. It is negative cos of x. Minus 5 is there. Cos of x's integration is basically just sine of x. Cos of x's integration is basically sine of x. Now, should I put C1 minus C2, C1 plus C2, or should I just put one constant? The answer is just put one constant, because constant minus constant is a constant. Constant plus constant is a constant. Constant multiplied by divided by a constant is another constant. So no need to put two constants, three constants, just put a single constant. Okay? No need to put multiple constants. Perfecto. So the answer is minus cos x minus 5 sin x plus c. Let's do this question. So here we need to integrate it separately. E raised to x dx is there as a first part, minus you have x raised to 1 dx as a separate part, and lastly leave that 1 by x as it is. Leave that 1 by x as it is. No need to bring it on the top, because we can't use negative 1 power of x for x raised to n formula. We need to convert it into logarithm. So e raised to x, special function, it is e raised to x. X raised to 1, integration is 1 plus 1 and 1 plus 1 over here. Plus this is nothing but log of x to the base e, and only a single constant, because no matter how many constants, it merges into one single constant. So this is e raised to x minus x square by 2 plus logarithm of x to the base e and the whole thing plus c. That is your answer. Is that right, my dear students? Perfecto. Excellent. So this is how integration is performed. I will give you a homework question before we again come back now. So this is your homework question, integration of 1 by root of x dx. Okay, how much is the answer? So this is your homework question. Put it in the comment section, and I want everybody to comment it, and we will see those names in the next class. Even if you're watching it recorded, it is perfectly fine. Just put it up in the comment section. All right. Okay. Let's do more questions coming up on your screen. Here it is. What is integration of 1 by x cube minus 5 dx? Integration of 1 by x cube minus 5 dx. Okay, try to figure this out. What is the integration of 1 by x cube minus 5 times of dx? Let's try to do this. Well, two terms, separate them out. Nothing else to do. 1 by x cube is separate, minus integral of 5 dx is separate. I can bring this on the top, so this will become x raised to minus 3 dx. 5 is a constant, bring it outside. I just have integration of dx. Okay, what is this? This formula I can use x raised to n, because n is not negative 1. So I'm safe. So this will become x raised to minus 3 plus 1 by minus 3 plus 1 minus 5. Integration of dx, I just gave it to you over here. It is just x, guys. Integration of dx is just x. So just put over there multiplied by x, and of course only a single constant. So this will become x raised to minus 2 by minus 2 minus 5x plus c. If you don't like it like that, I prefer a slightly better way, minus 1 by 2x square, because x raised to minus 2 is x square, and minus 5x plus c. So this is the answer for this integration. Isn't doing the basic integration very easy? This is the kind of things which you will usually do. Okay, right. So it will become x raised to x, it will become x raised to minus 3, correct? Somebody asked that, black hole, yes, correct. And that minus 3 plus 1. Only when n is not negative 1, you can use x raised to n formula. So that is the Main thing which you should realize. When n is -1, use logarithm formula. Use logarithm formula. Okay, sir, I did all this now. I have my basics clear about derivatives. Sir, and I also understood this indefinite integration. It comes with a constant, sir. Yes, very good. But sir, since you have written the word indefinite, I have a feeling that there might be something called as definite. And in the start of the class, you talked about areas and suddenly you are not talking about areas altogether. What happened, sir? Did you forget about areas? No, I have not forgotten. Deliberately, I did it because I first wanted you to understand this indefinite integration and what are the basic formulas. Now let's learn the definite integration concept. Okay. So basically, when I say I want to do a definite integration, definite integration. Okay, I want to do definite integration. It means something like this. Integration of your function f of x with respect to d of x, but I need to put the lower limit x1 and the upper limit x2. So the lower limit and the upper limit is that extra thing that you put. The moment you put that, see what happens over here. See what happens over here. Forget the lower and the upper limit for now. Just remember what was integration of f of x in general. When I told you integration of f of x, I said, see, f of x was the derivative of some another function. So the integration of f of x, is g of x plus some constant. So I can immediately say, yes, it is nothing but some new function who is basically g of x plus c. But that is indefinite, no, sir. Yes, correct. Remember, we did not worry about x1 and x2. We have just kept it at the back of our mind subconsciously. It's still there because there is something different in this integration. Till now, we never had lower limit, upper limit. That integration symbol was plain, blank, nothing on the top or at the bottom. The moment it comes, my dear students, we need to count that as well. So I'll put square brackets and I will put lower limit over here and upper limit over here. This is one way of representing it, or the other way of representing it is sometimes like this: g of x plus c. And some books also use this big line. It should not look like a small line, or else you will confuse it for the symbol of 1, the numeric 1, and put x1 over here and x2 over here. Both are exactly the same meaning. What it means is, you put the value of x2 here and then put the value of x1 here and then subtract both of them. So substituting the value of x2, upper limit is always first, and then substitute the value of the lower limit next, which is basically g of x1, and then you subtract both of them. That is the most important thing. Yeah, you need to basically subtract both of them. You need to basically subtract both of them. You need to subtract both of them. Now, see, guys, what happens the moment you subtract? Can you see? This constant and this constant just vanishes off. This constant and this constant just vanishes off, isn't it, guys? So what am I left with? What am I left with? I am just left with g of x of 2 minus g of x of 1. That's all I'm left with. So g of x of 2 minus g of x of 1. That's it. That is the final answer. There is no constant of integration. There is no doubt. There is no ambiguity. Because I'm certain about the answer. That is why I call it the definite integration. Because I'm sure. I'm definite. I'm indefinite. That means I'm not sure. So there comes a constant of integration. So constant of integration gets eliminated. So constant of integration constant of integration is not there only. It is going to get cancelled. Please keep in mind, this is not the same as, lot of people do this mistake. G of x2 minus x1. Lot of people do this, x2 minus x1. They subtract upper and lower limit and then put it over here. That is 100% incorrect. Never ever do this. Okay. So finally, our answer is as follows. So the integration of any function like this, the integration of any function f of x dx from the lower limit x1 to x2 is g of x2 minus g of x1, where g is representing that function whose derivative is f of x. Basically, you can also think of the antiderivative, or basically just the integration of f of x is g of x. Okay, so this is the formula. This is the formula of definite integration. Sir, it's looking beautiful, sir, but please tell me with an example, sir, only then it will enter my head. Correct, you're right. So I have to go for an example. Without that, you will not be so clear. So let's start with an example, guys. Do like this, do like this. Imagine I give you a question like this. Integration of x raised to 4, or let's say x raised to 3 dx from 1 to 2. Okay, Chumma have put some numbers. What you will do first is perform the normal integration without worrying about the limits. X raised to 3's integration, what will it be? X raised to 3 plus 1 divided by 3 plus 1. But don't write down any constants. And keep in mind, we have to tackle the upper and the lower limits. So keep it on the sidelines by the square bracket representation, just like I have told you over here. You can also use this line. So some books will also use this. They will write it down like this, x raised to 3 plus 1 by 3 plus 1. They'll put a big line like this. They'll put the number 1 here and the number 2 over here. This is also fine. There is nothing wrong about this. Okay, either this or right, either this. Both are correct representations. Upper limit, is it always bigger? Not necessary. Not necessary. Okay. Can we take G as common? No, no, my dear. G is not a multiplier. It is not G. When I write G of X, it is not G into X. It is not this. Okay. It is not a multiplying bracket. It is a function. It is like saying, when I say sine of X, does it mean S multiplied by I multiplied by N multiplied by X? No, right? It is just a representation of a function. Okay, so usually use those brackets and those small letter alphabets to represent those functions. Got it? Okay. Now, coming back over here, let's see. X raised to 3 plus 1 is x raised to 4 by 4. Let's not forget our limits 1 and 2. What did I tell? First put upper limit. That means instead of x, put 2. Okay. Then put lower limit, which is 1. Instead of x, put 1. And then subtract that. Never ever do this. Don't do this. 2 raised to 4 or 2 minus 1 whole thing raised to 4 by 4. This is definitely not correct. This is wrong. Okay. This separate and then subtract the 2. What is this going to be? 2 raised to 4, guys. 2 cube is 8. 2 raised to 4 is 16. Minus 1 by 4. 16 minus 1 is 15. So the answer is 15 by 4. Oh, that's it, sir. So easy. I got it now. All right. So let's do, guys, more questions on integration. More questions on integration. Let's do integration of, let's say I do 1 by x dx from 4 to 7. From 4 to 7. Immediately you should start thinking, sir, 1 by x integration, sir, I know it. Just forget the limits for now. Sir, I know it is log of x. Okay, fine, dear. Put log of x over here normally. Do not forget the limits because we have not yet tackled it. Just for our memory sake, we'll put it over here, 4 and 7 with the square bracket representation or the line representation, anything, is equal to, what do I need to do? First put 7 instead of x. So log of 7. Okay, sir. Then put 4 instead of x. So log of 4 to the base e. Then subtract both of them. But sir, I have learned something in logarithm, sir. What is it? Log of x minus log of y is nothing but log of x divided by y. If you have not yet learned, just assume whatever I am saying is true. You will anyways learn this in mathematics. For now, just assume whatever I have given is a formula which you will learn. Forget where it comes, how it comes, etc. What it means. Sir, I don't even know what log is. Forget. It is just a function like sin x, e raised to x, tan x. Yeah, it's a function. What does that function do? I don't care now. Just, just, just play along with me. So this is log of x minus log of y. Oh, sir. So this will be log of 7 by 4. Yes, correct, my dear. So log of 7 by 4 will be the answer. Log of x minus log of y is log of x by y. Got it? No, no, no. Don't put. No, no, no. This is not this. Some of you put log of 7 by log of 4. No, no, no. This is not true. No, no, no. That is not correct. It is log of inside parts, not log of this by log of this. Wrong. That is not correct. Some of you might make that silly mistake. It happens initially. When you do more practice with more mistakes, you will learn more. Okay, more mistakes you make, good it is. That is why when you solve problems, you make more mistakes and you learn a lot. And that's what improves your marks eventually. The student who has not made mistakes mainly has either not practiced or is very brilliant. I doubt usually the brilliant part is the case, because nobody is born brilliant. You become brilliant with practice and with efforts. Okay, so let's do the next question coming up on your screen. Yes, sir, I'm ready. Integration of e raised to x dx. Sir, always upper limit bigger than the lower limit, sir? No, no, no. Let's say I put the number 2 over here, or let's say minus 2 over here, and I put the limit, let's say 4 over here. Now you can see the lower limit is big, upper limit is small. Nothing wrong in that. Okay, there is no such rule. Upper limit means big. So all these are misconceptions. So let's say, what do we get from this? Forget the limits, just do the normal integration. E raised to x's integration is e raised to x only, sir. Okay, good. 4 over here and negative 2 over here. Okay, so instead of x, put negative 2. So instead of x, put negative 2. Instead of x, put lower limit, which is basically 4, and then subtract the 2. Then subtract the 2. Units measurements coming next one. Which book I follow for physics, Rama? If I show you the books which I follow, you will get shock of your life. You will faint. So you don't want to know, because I follow many books, because I am a teacher. But for my students, what do I recommend? If you are a 2-year student, you can go with Halliday and Resnick for only theory part. But no, sir, Halliday Resnick too complex English. For my English not that great, then go with H.C. Verma for textbook reading. Then coaching module. Tattva module is there with all of you. So if you have not yet got Tattva module, just order it. The link is there in the description box. Okay. So it looks something like this, the Tattva modules. These are our Tattva modules. You will get for every subject some 3-4 books for 11th, 3-4 books for 12th, and for every subject. So it's a collection of some 22-24 books. Okay, almost. Okay, sir. Then go to NCERT. And then if you want PYQs, if you are not happy with the number of PYQs in Tattva, because Tattva has good number of PYQs, but somebody will be like, sir, I want all PYQs. Then we have the PYQ book separate. Okay, so we have separate PYQ books which look like this. This is for NEET. Same book comes for JEE also. So you can buy that PYQ book. These many books, enough. Class notes, obviously mandatory. Apart from this, not needed. Okay. So what is this, sir? This is nothing but 1 by e raised to 2 minus e raised to 4. If you want to leave it like this, you can leave it like this. Or if you want to take LCM, then take it like this. 1 minus e raised to 4 into e raised to 2. So it will become 1 minus e raised to 6 by e square. Either this or this. Both are correct only. It's up to the options, how the options look like. Okay. Sir, but we are doing this definite integration. But I vaguely remember just when we started the class, you told that when you have these limits, it is basically the area under the curve. Yes, exactly. I told you whenever you have these limits, lower limit and upper limit, that is area under the curve. Oh, and then you just gave that example of this, and we told that is representing the area under the curve. So can we now exactly find out what is the area under this curve? The answer is yes. Let's find it out, how much it is. Let's find it out. The same question, I'm taking it over here. Let's take it over here. Can we find out the area under the curve? Definitely, why not? So just have to integrate it normally. What is integration of x square? It is x raised to 3 divided by 3. Do not forget the limits, number 1 and the number 4. So first put the number 4, so 4 cube by 3 minus, then put the number 1, so 1 cube by 3. 4 cube is 64. 1 cube is nothing but 1. 64 minus 1 is 63 divided by 3, that is 21. So the area of this area is exactly 21 square units. 21 square units is the exact area. Got it? Can we relate this to our life? 100% Abhijit. Many things around you are done via integration. Right from your gaming, right from the charts and the graphs which you might see in finance, right to the gyroscope which you have in your mobile, which does a lot of calculations, all right, on how you are tilting, how you are holding the phone. So many places. Yeah, so many places integration is used, right? Okay, fine, sir. Got it now. So give me a question on area. Very good. I will give you. Find the area under, find the area under y is equal to 1 by x square from x is equal to 1 to 3. Can you find the area under the curve of y is equal to 1 by x square from 1 to 3? Will I sit and draw the graph? No. No need. No need. I can directly do via integration formula. I know that the area under any curve is the integration of that function being 1 by x square respect to dx. Limits are from which place to which place. So from 1 to 3. That's all I need to do. Oh, this is 1 by x square. Huh? So I will put it as x raised to minus 2. That is a better way to do it. So this is 1, this is 1, this is 2. What is x raised to minus 2 is the integration? It is x raised to minus 2 plus 1 by minus 2 plus 1. Do not forget the limits. So this is 1. Oh, sorry. Why did it become 2? This was 3, right? Yeah, 1, 2, 3. Okay, sir. So what is this? X raised to minus 1 by minus 1. The whole thing 1 to 3. I can also write minus 1 on the top. It's the same thing, negative sign, upon x. Minus 1 by x, and this is 1 to 3. Now put the limits. See, all this was simplification till here. I had to carry forward those limits with the square bracket representation till this point, because now it looks good to solve. Otherwise, if it was here, substituting might make you confused. So now put the value of x. What is the value of x? It is 3. Then put the value of x, lower limit, which is 1. Then do the subtraction. So it is minus 1 by 3 plus 1, or it is 1 minus 1 by 3. 3 minus 1 is 2. So it is basically 2 by 3. So the answer for this area is 2 by 3 units. Okay. You can use square units after the integration. It is understood that it is square units only. Okay. Or the diamond unit of this into this. So it will be the square of both the units. It is understood. Yes, of J, because in our college there is no proper explanation. Never die. I'll tell you something. Never die. This channel has been a boon, has been a blessing ever since the COVID times for all the students, not necessarily who want to learn in English alone, but any student, even Hindi medium students. I see our channel analytics. Many students from Rajasthan, UP, or MP are watching our classes. Earlier, when we made this channel, we thought we will make this channel because nobody is doing in English, and even if people are doing in English, teachers are not that great. They are not NITians, IITians, and nobody is passionately doing it, consistently doing it, chumma for the sake of doing. If you do, ranks won't happen. You might get views here and there, because of somebody's face and this, but that is not why we started this channel, for views. We started this channel because of a pure intent that we want to give quality teachers, quality education for students who want to learn in English. And now I'm so glad that it is not just the English medium students, but Hindi medium or even other regional language students prefer learning over here, because obviously I give good content. I am consistent. You can see all the playlists are there, all the lectures are there, and even the live classes we conduct. We give you so much of strategies, information, don't do's, do this, everything timely on this channel. That is why you should be following all the lectures on this channel. If and especially if the college or your school is not explaining it properly, please watch the lectures. It is free of cost here. Okay, this is for you only, my dear. Okay, yeah, great, great. Oh, people from Kerala, Andhra, so good, so good. Let's do a very interesting question now. What is, oops, what is area under, area under the sin x graph from 0 to pi radian? For those of you who do not know what pi radian is, 0 radian is 0 degree only. Pi radian is basically 180 degrees. Okay, so this is the question. So let's try to figure this out. Area under the curve means integration for sure. Whose function? It is basically sine of x from where to where? 0 to pi radian. Okay, fair enough. What is integration of sine of x? It is negative cos of x. Okay, let me put these things over here. This is lower, this is upper. Now, let's put the upper limit first instead of x, so it will become minus cos pi. Then let's put the lower limit, which is 0, so minus cos 0, and eventually subtract them. See guys, pi is nothing but 180. Cos of 180 is basically negative 1. Cos of 180 degrees, you should know this. Cos 0 is 1, so cos of 180 degrees is negative 1. This is cos 0. Cos of 0 degrees is just positive 1. So what do I get over here? Minus cos 0 is just 1. Minus minus 1 is positive 1. Minus minus is also positive 1. So the answer is 2. If you look at it graphically, what it means, if you look at it graphically, what it means is that this is your y-axis, this is your x-axis, this is x, this is sine of x, this is your 0. We all know that our sine x graph looks like this. This is pi radian. This is 2 pi radian, which is 360 degrees. So when I asked you to find the area from 0 to pi, what we have essentially found is basically this area. What we have found is basically this much area. So this much area is 2 square units. That is the meaning of it. 2 square units. Cool. Now, let me play around with this. See guys, let me play around with this. Imagine, I tell you, can you find integration sine of, or let's say, cos of x dx, 0 to pi? Same thing, same question, but the function has been changed. Instead of sine, I have made it cos. Now, obviously, you can do it properly. You can do it properly. And integration of cos is basically sine of x. The sine x derivative is cos of x. And then put 0 over here and pi over here. And then you put sine of pi. And then you put sine of 0. Now, please keep in mind that sine of 0 degree is 0. Sine of pi means sine of 180 degree is also 0. So, it turns out that this will be 0 minus 0, which is a big fat 0. So, I did it properly and I got the answer as 0. But when you see the graph, things start becoming even more clearer. So, say for example, this is our x, this is our cos x, This is our 0. Cos graph starts from 1, goes like this, and like this. This is 2 pi. This is pi. This is 90 degree. Cos 90 is 0. Cos 0 is 1. Cos of 180 is minus 1. This is how it goes. Now, when you see it, things start becoming clearer. I'm trying to find this particular area. This area is positive and this area is equally negative. So together it cancels out. So when you find areas under the curve, you need to account for these signs. If something is on the top, it is positive. Something is below, it is negative. So that is why the answer is 0. That is why the answer to this is 0. Got it? Yeah. Now, imagine I tell you a function like this, or I ask you, hey, can you tell me integration of sine of x dx from 0 to 2 pi? Guys, sine of x function, think about it. Sine of x function, how will it look like? It will be like this from 0 to 2 pi. So when you try to find the area, this area will be positive, this area will be negative. So this positive and negative area will cancel out. Hence, the correct answer to this will be a big fat 0. The correct answer to this function will be 0. Got it? So sometimes you don't have to even solve the question. Just because you know the graph, you can easily do it. Just because you know the graph. Let me give you another question, guys. Let's see if you guys can do this. Integration of sine of x from negative pi by 2 to positive pi by 2 dx. Come on, guys. Negative pi by 2 to positive pi by 2. Okay. So I have to go on the negative side also, sir. Yes, definitely. So it will look probably like this. This is pi. This is negative pi. This is minus pi by 2. This is positive pi by 2. So if you go from minus pi by 2 to plus pi by 2, you have a negative area and you have a positive area. They both will cancel and hence the answer will be a big fat 0. But let's say, for example, I do integration of cos of x dx from negative pi by 2 to positive pi by 2. I feel this answer may not be 0. And see, graphically, you can very easily visualize it. Graphically, very easily, you can visualize it. See, the graph of it goes like this, like this, like this. This is basically 2 pi. This is basically pi by 2. This is basically negative pi by 2. This is 0. So as you can see, this area and this area both are positive and positive. So 100% it will be a positive answer. But I'll tell you one thing. Don't you see this particular part resembles resembles this particular part of the sine curve? Come on, put up the answer in the chat box. Yes or no? Yeah, can you see that, guys? Perfectly. Yeah, this particular part exactly resembles this part of the sine curve. You can just shift it. Just shift this dome over here. The answer for this area was 2. So 100% without even solving, I can say it will be plus 2. Yes, it will be plus 2 directly. If you solve it also, you will get it as 2 only. So this is the meaning of areas and integration with limits. So we saw that geometrical figures, easily we have the formulas to calculate the areas, which I showed it to you at the beginning itself. But in physics, we need to find the areas of curves for various reasons, and we cannot use our traditional methods. So that is why we developed a new process called as integration. And in this integration, you basically integrate a function with respect to x from a location to another location between which you want to find the area. This method is called as definite integration. And to see the formula for definite integration, we started off with indefinite integration, where you always have a constant of integration. And then we slowly saw the formulas for all the different functions. We saw how to integrate these functions with different rules. And then we switched over to definite, which is not going to have any kind of constant. That constant gets eliminated. And then that definite integration only gives me the area under the curve in all these cases. So that was your basics of integration, my dear students. This is your homework question. Root of 1 by x dx. Okay, what is the answer? It's a indefinite integration. And if you are loving the way I teach, let me tell you, at our offline centers too, you have awesome teachers just like me, who are themselves qualified in all these entrance examinations and are trained to make a below average student above average and a topper. So if you want that personalized coaching, not a batch with hundreds of students, if you see our centers, they barely have a seating capacity of 30 to 50 maximum. Classrooms are digitized. There are student academic mentors to know your progress, growth, shortcomings, attendance, interacting with your parents, parent-teacher meetings, everything. Plus, you have doubt counter faculties. So, all of this with our amazing content and all the fun elements, whatever you need to crack JEE NEET exam, all in our Vedantu learning centers, and a new center opened at JP Nagar in Bengaluru, many other centers in Tamil Nadu, Andhra, Telangana, Karnataka. We already have so many centers tied up with Diksha. By the way, Maharashtra, Punjab, Delhi, so many places, guys, we are spread across. And also, when you are visiting the centers, please book a slot along with the scholarship test, which you will be able to give at the center. And you can get up to 90% of scholarship, depending on your test scores. So if you are planning for a 1 year or 2 year long course, this is the test which you need to give. The link for booking the slot is there in the description box. You can see explore our offline centers, book a visit now. So please book a visit. You will be able to get the exact location, and you will be registered in a proper way. You can confirm a time slot to meet our counselors. Enter the phone number, just pay a visit. You can see so many centers are there across our country. Okay, so just pay a visit, see how it goes. If you like it, go ahead. If you don't like it, it's okay, perfectly fine. Okay, I'm always there for you over here on YouTube. Okay, so thank you so much. Make sure you're liking the video and subscribe to the channel. This was your Captain Shreyas signing off. Answer in the comments. PDF will be shared shortly.